Iterators are a generalization of pointers that allow access to STL containers with a consistent interface. Let's open up iterator.cpp. I'm going to copy this and paste it into our working project and open it up here. I'm just going to maximize this. So there are basically 5 types of iterators. There's an input iterator that allows reading from an iterator object, and the input iterator does not have what's called the multipass guarantee. That is, it can't guarantee that it'll reread an object and produce the same result. A forward iterator allows reading from the iterator object with the multipass guarantee. That means that rereading an object is guaranteed to produce the same result. A bidirectional iterator allows reading from the iterator object both forward and backward and with the multipass guarantee. A random access iterator allows reading from the iterator object randomly, and again with the multipass guarantee. And an output iterator allows writing to the iterator object, and it may also iterate forward without the multipass guarantee. So let's take a look at these 5 types of iterators here in this program. I'm going to bring this back down to size, and we'll press the big green compile and run button. And we have here a vector that's initialized from an initializer list because I like doing it that way. And that's a feature of C++11. And I've declared an iterator here so that you can see how that declaration looks. And so whatever the base type container is, and then the 2 colons that say that this is a member of the class, and the iterator, which is actually a type member of that class. And so that all together makes the type of the iterator, and then the name that you're going to give the variable. And so we've declared another one here, and we call this beginning, and we're initializing it to the value of the begin method of the vector vi1. And the begin method in a container generally will give you an iterator to that type. There's another way to do this with C++11, and this is a C++11 feature. And that would be to use auto here for the type, rather than all of that long declaration of that type of iterator. And the auto feature, again, it's a C++11 feature. It's becoming very common because it's really, really convenient. It allows you to declare the type of a variable based on the return value of a function or another object. And so in this case, because vi1.begin returns this type of an iterator, I can declare this variable and it will automatically be that type. For now, we're just going to leave this like this, and you can see how that feature would be a whole lot more convenient than typing all of this stuff. And this can actually become even more complicated with more complicated declarations of containers. So now we're going to demonstrate an input iterator. And remember, an input iterator allows reading from an iterator object, and it basically allows it in one direction and once. And after it's gone through once, you have no guarantee that you can go through it again. And so this might be a type of an iterator for something like a database or a single directional type of a list with dynamic values. And so here you see we start at begin, and while the iterator is less than the end, it iterates forward, and it prints out what's pointed at by the iterator. So basically, the iterator type overloads the pointer dereference operator, this asterisk, and it allows it to operate just like a pointer in circumstances like this. And so we can access it just like we would a pointer to the type that the iterated object has as its base type. So here, this input operator, and you can see right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It works like that. It's just stepping from the beginning to the end, and you're incrementing the iterator just like you would a pointer. Next, we're going to look at the forward iterator. And in this case, a forward iterator allows reinitialization to the beginning and allows you to iterate over those same values, and you're guaranteed to get the same results. So here we've saved that beginning value. Remember, we did this at the beginning there on line 12. And so with that saved value, we're initializing our iterator and then stepping through it just like we had before. And we're getting the same result. So that means that the vector type supports the forward iterator and the input iterator. Actually, the vector type supports all of these types of iterators, which is why we're using it as an example here. A bidirectional iterator allows you to iterate backwards. So it allows the decrement operator on the iterator. And so here you see we're starting from the last element in the array because we had iterated just past the last element on the previous one. And as long as we're greater than or equal to the beginning, we're going to decrement the iterator. And you can see that that works. Here we've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The random access iterator allows plus equals and minus equals. And so here we have some examples of that. And you see we're printing 8, 5, and 9. And then the output iterator allows you to write to an object via the iterator. And so here we're starting the beginning again, and we're going to the end, and we're writing zeros all through this vector. And then we iterate through it starting at the beginning, and you can see we get all zeros on our output. So those are the 5 types of iterators: input iterators, forward iterators, bidirectional iterators, random access iterators, and output iterators. Some container types in the STL support some types of iterators and not other types of iterators, so it's important to understand these. Iterators are a tool for working with STL containers, and STL iterators allow you to iterate through a number of different types of containers with a common interface. So let's delete our working file and